Hey guys, this is Mrs. Keith, and I'm doing notes today over parallel and perpendicular lines. In this first paragraph, I'm kind of explaining why we need to learn these. When we do things like parallelograms, we have to worry about whether or not the opposite sides are parallel to each other. When you talk about a rectangle, you have the side and the base that are perpendicular. The height of a triangle has to be perpendicular to the base. So if we've drawn these figures on a coordinate grid, you need to know if lines are parallel or perpendicular to each other. So we just need to make sure we have a strong foundation on that. So I've reminded you about the slope formula right here. It's y2 minus y1 over x2 minus x1, which is basically the change in y over the change in x, or you might have learned it as the rise over the run. So I've got two lines right here where we can calculate the slope. For the first line, notice that as you read it from left to right, you're going up, and so that's going to be a positive slope. On the line to the right, as you read it from left to right, you're going down, so that's going to be a negative slope. So something to think about when you just look at the line from the beginning. I'm going to choose 2 points, and I've got them marked on these grids to calculate the slope. I'm going to see how far I go up. I go up, let's see if I can make this mark, up 2, and I go to the right 3. So that's going to be a positive 2/3 slope. On the next line, again, I have 2 points clearly marked. I'm going to go down 1, 2, 3. And then I'm going to go, so I went down 3, and then I'm going to go to the right, 1, 2, 3, 4, 5. So that's a negative 3/5 slope. All right, so just a reminder of how to calculate slope. I've also got two other formulas that you need to focus on, which is point slope formula and the slope intercept form. When we have it in this form, that allows us to know what the slope of the equation is. So it's better to get your equation in that form. All right, let's move on to some more. Okay, this is asking us to look at this picture right here, and it wants us to calculate the slope of segment UV. Well, I'm going to choose this point right here, and I'm going to choose this point right here, and I'm going to see how much I rise and run. So I go up 2 and to the right 1. So if I go up 2 and to the right 1, my slope is just 2. I'm going to do it for WX as well. I'm going to choose this point here and this point here. I go up 2 and to the right 1. So again, my slope is 2. For YZ, I go up 2 and to the right 1. So my slope is 2. Now it's asking me to do the slope of UY. Well, I notice automatically it's negative because as I read it from left to right, it's going down. So if I choose a point, I'm going to choose this point and this point to calculate the slope. I go down 1 and to the right 2. So I go down 1 and to the right 2. That's a slope of a negative 1/2. So hopefully you can see just by looking at these that these that I'm highlighting in yellow, this segment, and this segment, they all look parallel. Well, how I can know that for sure is that they have the same slope. So slopes of parallel lines are the same, and that's what we want you to always remember. The slopes of parallel lines are always the same. Now these two lines, let me change my highlighter, sorry. Let's see, this line and this line, those are perpendicular. Actually, all of those parallel lines are perpendicular to this green line that I highlighted first. And if you'll compare their slopes, this slope and this slope, they are negative reciprocals. And what I mean by that is that they have the opposite sign and the fractions are flipped. So you had one slope that was 2, it's understood to be 2 over 1, and the other slope was a negative 1/2. So they have opposite signs and the fractions are flipped. Okay, let's do some more practice. Okay, remember we said that lines that are parallel have the same slope, and lines that are perpendicular are negative reciprocals. I'm just going to abbreviate that. So I'm going to look at this line. As long as it's in the form y equals mx plus b, I know that this m value, the number in front of x, that's my slope. Well, this equation that they gave me, it is in that form. So this number right here, the 3/4, that's the number in front of x, and so that's going to be my slope. So the slope of this line is 3/4. So a line that's parallel to it has to have the exact same slope, so it's also going to be 3/4. A line that's perpendicular has to have a different sign, so if this one's positive, the perpendicular line has to be negative, and you have to flip the fraction, so it'll be 4/3. So a line parallel will have a slope of 3/4, and a line perpendicular will have a slope of negative 4/3. All right, now let's determine from these three examples below if these lines are parallel or perpendicular to each other. Now remember, you're going to have to, let me erase this, you're going to have to put it in the form y equals mx plus b to truly know what the slope is. None of these are in that form. So if I take that first equation on number 1, y minus 2x equals 5, and I get it in that form, I need to move the 2x over, so it becomes y equals a positive 2x plus 5. Now it's in that form. Now I'm going to take the other one. 2x minus y equals 4. Move the 2x over, so it's negative y equals a negative 2x minus 4. Now I'm going to divide through by negative 1 because you have to have y by itself. So that becomes y equals 2x plus 4. Now these two lines both have a slope of 2. Since the slope is the same, then these lines are parallel. All right, let's do it for number 2. And I'm going to erase what I just did so that we have plenty of room. You can rewind if you need to see that work again. Okay, I'm going to take the first line, x minus 3y equals 6, and move the x over, so it becomes negative 3y equals negative x plus 6. Divide everything by negative 3. And I'm left with y equals, this becomes a positive 1/3 x. It's understood to have a 1 right there, so the negatives cancel and you're left with 1/3 x minus 2. The other equation, 3x plus y equals 1. I'm going to move the 3x over, so it's y equals negative 3x plus 1. All right, comparing these slopes, this one has a slope of negative 3. This one has a slope of 1/3. Those slopes are negative reciprocals of each other, so these two lines are going to be perpendicular. All right, now let's do number 3. I think I can squeeze this one in. So I'm going to take the first equation, y plus 3x equals 10. Move the 3x over, so we're left with y equals a negative 3x plus 10. The other equation is 3x minus y equals 7. I'm going to move the 3x over, so that's negative y equals a negative 3x plus 7. Divide everything by negative 1, so that becomes y equals a positive 3x minus 7. Now if you look at these slopes, this is negative 3, this is positive 3. They are not the same, so they're not parallel. They're also not negative reciprocals. They do have different signs, but the fraction hasn't been flipped. So we would say that these are neither. They're not parallel or perpendicular. All right, let's move on. Okay, on this page it says you can use the point slope form, which remember is y minus y1 equals m times x minus x1, to determine the equation of lines with a particular slope that passes through a given point. Well, m in this formula represents the slope, and x1, y1, that represents a point on the line. Okay, so when you're replacing numbers into this formula right here, this y1 will be replaced with this y1. This x1 will be replaced with this number that's right there. And then this slope will be replaced with whatever your slope is. The y and the x that I have not highlighted, they're going to stay just y and x. All right, let's do an example. This says write the equation for a line that is parallel. That means you have to have the same slope. to the line y equals 5x plus 3 and passes through the point 4, 0. Well, this point, that's your point that the line has to have on it, so that's your x1, y1. This is the slope of your original line. And so your line that's parallel has to have the same slope. So when you use your formula, y minus y1 equals m times x minus x1, you're going to replace y1 with the y value, 0, equals, m is the slope. My slope is 5, according to that equation, so replace that m with 5. And then x minus the x value is this number 4. All right, so you've plugged in the numbers. Now you just need to simplify it to get it in slope-intercept form. So y minus 0 is just y. I'm going to distribute the 5, so that's 5x minus 20. This is the equation of the line that's parallel to this line, and it goes through that point 4, 0. Okay, let's do another one. Okay, on example 2, you're going to write the equation of a line that's perpendicular. That means your slopes have to be negative reciprocals. And you're going to do that perpendicular line to y equals 4/5 x plus 8 and passes through the point 12, 7. So this is your point, your x1, y1 that you're going to plug into the formula. This is the slope, so slope equals 4/5 for the original line. Your perpendicular slope has to be negative 5/4 because you take that original slope and you flip the fraction and change the sign. Okay, so y minus y1 equals m times x minus x1. I'm going to do y minus, the y value is 7. So y minus 7 equals my new slope for my perpendicular line will be a negative 5/4. And then x minus that 12 right there, because that's your x1. All right, multiplying this out, or simplifying it, I have y minus 7 equals, I'm going to distribute the negative 5/4, so that becomes negative 5/4 x. And then I'm going to multiply negative 5/4 times a negative 12. Just to make that clear, when you do negative 5/4 times a negative 12, basically you're doing negative 5 times a negative 12, which is 60, and then 60 divided by 4, which is going to give me a positive 15. Okay, we were trying to get y by itself to put it in slope-intercept form, so I'm going to add 7 to both sides. 7 will be added to that 15 because they're like terms. So you end up with y equals a negative 5/4 x plus 22. And that's your answer. Okay, let's do another one. Okay, on this one, we need it to be parallel. This line has a slope of a negative 2/3. So your parallel slope will also be a negative 2/3. Your new line has to go through this x1, y1. So plug it in your formula. It'll be y minus 2 equals a negative 2/3 x minus 9. All right, so multiplying that out, a negative 2/3 times x is a negative 2/3 x. And then negative times a negative is a positive, and when I do 2/3 times 9, I get 6. Okay, so now I'm going to add the 2 to get y by itself, and I end up with y equals a negative 2/3 x plus 8. And that's your equation that's parallel to this original line, and it goes through this point 9, 2. All right, one more of these. We're going to do a line that's perpendicular to this line. This one has a slope of a negative 6. Your perpendicular slope will have to change signs, so it'll be positive, and you flip the fraction. Remember, this is understood to be over 1, so this will end up being 1/6. And it has to go through the point 18.5, so that's your x1, y1. So plugging it into your formula, you've got y minus 5 equals 1/6 times x minus 18. So y minus 5 equals 1/6 x, and then 1/6 times 18 is going to be 3. Then I'll add 5 to both sides, and I end up with y equals 1/6 x plus 2. And that's your answer. All right, let's do a little bit more. Okay, on this one, they're wanting you to notice that we've got some horizontal and some vertical lines. So first of all, they want to make sure you understand the slopes. The slope of a horizontal line, so the slope of this horizontal line right here, that's going to be 0. All horizontal lines have a slope of 0. It asked me to extend the line, which I did with the highlighter. What would the equation be? Remember, all horizontal lines have a y equals equation. So this is going to be y equals 12. That's the y value that this line goes through. So it's y equals 12. What is the slope of KG, which is this line right here? Well, it's undefined. Any vertical line has an undefined slope. And then if we extend the line, which I did, all vertical lines have an x equals equation, and it's whatever the x value that it goes through, which is 4. So that's x equals 4. What can we say about horizontal and vertical lines? Well, all horizontal lines are parallel to each other. All vertical lines are parallel to each other. If you take horizontal and vertical lines, they are perpendicular to each other. Okay, so let's do an example. It says write an equation for a horizontal line. A horizontal line has to be a y equals equation. And for a vertical line, that has to be an x equal equation that passes through the point 2, -1. And I'm just going to kind of graph that real quick. We've got 2, -1, which is right here. So if you were to graph a line that's a vertical line up and down, it'll look like that. So it's got to go through that x value of 2 right there. So your equation would be x equals 2. That goes through that point and it's vertical. If you did a line that's horizontal, let me change the color of that. Okay, a line that's horizontal going through that point, then it's going to be a y equals equation, and the y value is -1, which happens to be the same y value as that y value in the ordered pair. So those would be the answers for that question. Okay, on example 6, write an equation for a line that's parallel to the line x equals 5. This is a vertical line. I know that because it's an x equals equation. So if I think about the graph of that, x equals 5 will be a vertical line that goes through where x is 5. And we want a line that is parallel and goes through the point 1, 3. So this point right here. And it also has to be a vertical line. So that's just going to be x equals 1. Again, it'll match that x value since it's a vertical line. Okay, example 7, write the equation for a line that's perpendicular to the line x equals 3. This is vertical. A perpendicular line will be horizontal. So if I'm going to write a horizontal equation, it has to be y equals. If it has to go through this point, I just want the y value of that point. It's going to be y equals 7. If you think about the graph, the point 2, 7, it's going to be up here. So a horizontal line that goes through that point would be right here and be y equals 7. All right, one more thing to learn. Okay, so the equation of the line shown on the coordinate plane is f of x equals, it's 3/2 x plus 6. Let me see if I can scroll that down just a little bit, sorry. Okay, 3/2 x plus 6. Draw the shortest segment between the line and the point -111, which is labeled for you. Label the point where the segment intersects the line as point B. And I want to make sure you understand this right here. The shortest distance has to be perpendicular. So I need to figure out what the slope of this line is, and it's easy. I should know it from the equation. It's just 3/2. So the perpendicular slope would be a -2/3. So if I'm going to draw a line from point A to this line, and it has to use this perpendicular slope, I'm going to go from this point A, I'm going to go down 2, and to the right 3, and that'll be a point on a line that's perpendicular. Let me see if I can draw this. On a line that's perpendicular, to that line. All right, it wants to know what the shortest distance is between this point A right here and this point right here, which is a point on the line. So what's this distance right here that I've marked in blue? Okay, so what do I need to calculate the length of this? Well, you need to know what point A is, which is a negative 111, and you need to know what point B is. By the way, I forgot to label this point right here, B. And it's at the ordered pair 2, 9. All right, you need to know what those points are so that whenever we ask you how far away is point A from the line, which basically would be at point B, we're going to do the distance formula, which remember is change in x squared plus change in y squared, or you may do the formula x2 minus x1 squared plus y2 minus y1 squared. All right, if you think about how your x's changed, they changed by 3 right there. So change in x was 3 squared. My change in y was 2, so plus 2 squared. That's the square root of 9 plus 4, which is just the square root of 13. So that's how far away point A is from that line. All right, guys, that's it. Thanks.